Hello everyone, this is Chris Mackey and welcome to your introductory video on Honeybee energy modeling. This is the first video in a very long series that we've put together for you guys here. And in this video we're just going to give you a very broad overview of all the things that we're going to cover in here. We're not going to delve into rhino or grasshopper yet. This is just to give you a sense of the stuff that you will find in this series. That is on Honeybee energy modeling. But just to give you guys a little bit of a overview from the start. Sorry, there we go. So Honeybee, as you guys may already know, does a lot of different things. I mean, it connects Rhino Grasshopper, our wonderful 3D geometry interface, to a number of different open source platforms for daylighting, Radiance being a rendering engine, DaySim being a tool for evaluating daylight. And you can also export to a GBXML, which is becoming a sort of standard for a lot of energy modeling. But the focus of this series is going to be on the connection between Rhino Grasshopper and these two, which are Energy Plus and OpenStudio. And these are projects funded by the Department of Energy that are open source, very good ways of energy modeling, fully energy modeling buildings. But now, just to sort of open though, I mean, just to give us some general advice on energy modeling, and I mean, I give this just because I know I had struggled for the last 2 years to try and integrate energy modeling into my design, and there were just a few things I learned along the way that I wish someone had told me sooner when I was starting out. And so I wanted to tell you guys this at the start of this video series, just so you guys have a sense of what you're getting into and you know, what you have to put in and what you'll get out of it. So first thing first advice I would give to you is that energy modeling is difficult. That is just it is a fact. It is, and anyone who tries to tell you otherwise has not really delved deep into energy modeling or used it extensively. And the reason why it's difficult is because even the simplest building that you have is subject to a lot of complexity in terms of the weather and can be used in very complex ways by its occupants. And it's because of this that energy modeling is always going to be a very complex task that involves looking at some details. But because of this complexity, you know, even if you have a fast means of setting up energy models, and I will say Honeybee, it can be a very, very fast way of setting up energy models, primarily because it cuts out the most time-consuming step of recreating the geometry by virtue of the fact that we're plugged into Rhino. But even though it's very fast, one, you still have to take time to understand all these complex inputs of your model, all this complex weather and complex, you know, user variables. And two, it'll take a lot of adjusting of these very complex inputs before you trust that your model is an accurate representation of what you will build. And this is why, I mean, because it's relatively easy to just, you know, have a model and run it, but to actually trust it and get something useful out of it is a difficult task. And to maybe sort of explain this a little more, or maybe to kind of ask, like, if it's so difficult, is it worth it to model at all in the design process? And I will say, you know, there are actually some people who say that, you know, designers maybe shouldn't be energy modeling, if only because it can be this very difficult, time-consuming task. But I mean, of course, the opinions vary widely on this, and you can imagine that I fall more on the side that yes, as a designer you can energy model, but I would say I would give this advice in terms of how you model in your design process, or essentially when you start to energy model in your design. And I would say that you should first make sure that you have gotten some ideas from, you know, just by exploring the climate. I mean, and using Ladybug as kind of as I suggest here, because we made Ladybug primarily so that you can explore the climate and, you know, and find interesting things that you might not otherwise have realized, and get ideas about strategies and things that you might want to implement on your building. And the thing is, you really, really need these ideas in order to energy model, because the energy model isn't really going to give you the ideas itself. The energy model can tell you how good the idea is and how much it's working or not working, but really, like, these ideas need to come from an exploration process that is, you know, better done with visualization tools like those that you'll find in Ladybug. So 2, you have ideas from Ladybug. 2, you should have exhausted the usefulness of Ladybug to inform your design. So Ladybug has a lot of different things, that you can just basically use to start testing and maybe creating some simple geometries around stuff in the weather file. So, but I mean, at a certain point, you will exhaust the usefulness of this in terms of how it can inform your design, and then you can start to energy model. But there's one other requirement, I would say, in terms of using energy modeling successfully in your design process, and that is you need to do it while you still have enough time to devote to understanding the energy model, and so that you can perform several iterations of this, because that's really where you pull the most value out of your energy model. And so, I mean, I give this kind of graph here of a typical traditional design timeline. So really, I mean, like Ladybug is meant more for the brainstorming and schematic design, but probably, sometime pretty early in your design process, or around schematic design and design development, you can start. That is when you should probably start modeling some stuff in Honeybee, if only to test stuff out and get a very basic initial model of what's going on. And then, by the time you're up to construction documents, then you're using something that you could really model the HVAC and a lot of other very intricate details better, such as OpenStudio or one of the programs where you can export the GBXML to. So that's kind of like that. I mean, this is the kind of sweet spot in your design where you should be considering energy modeling. So I mean, just to explain this more. So I mean, why is it important to start early like this? I mean, so after you've gotten ideas, but while you still have enough time, why is that time important? And I mean, to kind of walk you through it, I mean, what happens when you try to energy model? I mean, first, okay, you've got your zone geometry that you create in Rhino. You got your geometry of your buildings and these rooms essentially, which are zones. And you'll assign all these zone properties like constructions and schedules and the amount of lighting and people in the space and everything using Honeybee. And then you'll change all the properties, because you'll have default properties, but then you'll have to change all of them to reflect what you will build. And then finally, okay, then, after you've got that, you're ready to run the model and you load and visualize the results. And a lot of people say okay, that's energy modeling. That's what we have to do in order to do it in our design process. But the reality is that almost any time, the first time that you run through this process with your energy model, almost certainly you're going to get garbage out of the result. And that's it happens because, it's what you will build is usually something that is much more complex than just the defaults of what you're going to be setting. So the thing is, really, if you're going to start to pull value out of this, you have to look at those visualized results and really try and understand them and understand what's going on in the model, why things are the way they are. And then after you understand that, then you can go back again and change some of the properties to actually reflect what you will build. And you'll probably have to do this several times in the course of your design until finally you'll get out of this, you'll get something useful. Like something that actually represents what you would build, and at the least, now you've got something that can tell you how much your energy is going to be, and you can bring that to a developer and tell them you save this much money on M&O, and so you have value there. But the thing is that, the value that you pull from just having an accurate representation of your model isn't nearly as powerful as the value that you will pull once you're able to go back then in this final sort of stage of actually designing with the model and now understanding the results and using your understandings that you gain from this to try a different strategy. And and this again becomes a cycle, and it's in this last part that you really pull out a lot of value of your model. And unfortunately, I feel a lot of the times today, and especially a lot of times in my design process when I first struggled with this, it was a real challenge to get to this final last place. But out of it is, you get a great design. You not only just get a something useful, you get something that really improved your design. And to sort of kind of visualize how this value happens on a graph. If you have your value drawn from a model on the x-axis versus the time you invested in it on the x-axis, and this is the y-axis, then in the first part when you're just setting up the model, you're kind of going into the red. You're investing a lot of time without with just getting garbage and not really necessarily drawing anything out. But as you begin to understand that and work through it, and then you finally get something that is, sort of representative of reality, you're at the break-even line. You're all right. The time you've invested is at least paid off in some respect. But the thing is, I mean, it's a kind of exponential curve from here, because like once you have that model, then you're able to run through it very fast and pull this increasing value out of the model as you use it to really inform your design and make it better. And this is the type of thing that I want to be seeing in the next 5 years in all of design practice. And if this is what you want to see too, then you're in the right video series right now, because that's the goal that we're trying to aim for. And so, but I mean, because the real power of what happens along this blue line here is that it's going to be something that's very similar to the way we'd imagine that a lot of the vernacular architecture forms emerged. So you can imagine how like the igloo emerged from something that was in a less extreme latitude, and I mean, it was probably very counterintuitive at first to think, oh, snow could actually be a good insulator even though it's very cold. And gradually this but if someone just tries to dig under the ice, you get your heat flowing out. And so gradually over time, through this like process of trial and error that lasted centuries, you eventually got the igloo, where you're sort of coming in and up so that the heat gets trapped in there, and you get these incredible properties. And I mean, and there are a lot of vernacular things evolved this way. So I mean, such as the Iranian ice house, the Yaktal, evolved this way. From just people noticing that when they put the ice in underground, that would stay for longer. And this evolved in this big, large system where you had a flat, shallow pool to help you harvest the ice, and then create the ice, and then you shaded it from the sun. So all these, there are countless other examples of this. Perhaps a good example of a modern one would be one of my favorite architects, this guy named Mike Reynolds, who, after he was disillusioned with some of the things he learned in architecture school, he sort of just went out to the southwest U.S. and just started building stuff, and just building these crazy forms, mostly using waste streams from the U.S. And he had tried all these different things, all these different various combinations of the things in the waste stream. And over time, I mean, he went through this process of trial and error. I mean, sometimes he had so much glazing, and his buildings would completely overheat when the sun came in through there. But other times, they were too deep and not enough sun came in, until he finally arrived at like kind of what is a modern vernacular. Where he had dimensions that made sense, and he knew that he can control the temperature well if he kept the depth of it constant, and that's what he termed an earth ship. And this took this man his entire life of experimenting and trial and error to arrive at this thing. And the power of energy simulation is that you can get to this place, like this place that normally takes centuries or at least a person's lifetime. You can get there in a matter of a month. You can know that this building was going to overheat. You can know these things. And because of that, you can make some very, very powerful designs very, very quickly. And so if you guys so you have to invest a lot, but this is the huge payoff that you get out of this. And if you're in it for this type of thing, then this is the right video series, and you're going to really enjoy what we have for your year. So all right, so with that preamble, you guys know what to expect roughly in this series. And in the next one, we're just going to talk about installation of the tools. All right, I'll see you in the next one, guys.